All right, guys, this is lesson 11.2. All right, we're going to be talking about areas of circles and sectors. On Friday, we talked about, I think it's Monday here. Losing track of my days. We talked about circumference and arc length. Okay, so it's very similar to that. So if you found that not to be terrible, this is the same. You're just setting up proportions. Okay, so first thing, let's talk about what area of a circle looks like. So area of a circle formula is right here. Area is equal to pi times r squared, where r is the radius. Okay, so we're going to find the area with radius of 14. So the area is equal to pi times 14 squared. So you get your little fancy calculator out and you're like, all right, pi times 14 squared, and we round to the nearest tenth, gives us 615.8 inches squared. Remember, area is always units squared. I am going to be looking for units when you take this test, so make sure you're writing your units down. All right, so find the area of a circle with diameter of 12.6. Well, that's weird. So that means I need to find the radius. So the radius is twice the diameter. So 12.6 divided by 2 is 6.3. That is the radius. So now we can find the area equals pi times r squared. 6.3 squared. Get out your fancy devices. Pi, wait, what? Pi times 6.3 squared is 124.7 inches squared. 124.7 inches squared. All right, now, the next one says we need to find the diameter of a circle whose area is 125 inches. So we're going to use this formula here, up here, pi r squared, excuse me, and we're going to find r, and then we're going to times it by 2 and find the diameter. So we're going to plug in 125 for area equals pi r squared. The first thing we need to do is divide by pi. All right, so 125 divided by pi, and I round to the nearest tenth, that gives me r squared is equal to 39.8. Right, so if I take the square root of both of those sides, right, because that's how we unsquare something, we take the square root, r is equal to, and again, I'm going to round to the nearest tenth, 39.8, that gives me 6.3. And we times that by 2 to find the diameter, right? So D is equal to 6.3, I'm just going to put in parentheses, times 2. Ooh, the diameter is 12.6 inches. It's funny because it was, we had a diameter of 12.6 inches up on the problem before it, but the area was 125. So perhaps they just rounded up. But you see how that was pretty interesting. Pretty interesting. That's how you do it, okay? You just work it backwards. Plug it into the formula. Area, pi r squared. If you need the diameter, find r, and then multiply times 2. All right, what is next? All right, now, sorry about that. Sector of a circle is the region bound by 2 radii. There's a radii and there's a radii. So it's like a piece of the pie, okay? And then this is the intercepted arc, right? So this sector of a circle is like this, all this gray part, this little piece of the pie, okay? I think you have the circle on your picture. All right, so the intercept, the radii, PA and PB, and the arc is AB. All right, just to explain that, okay? So this is the radius, This is the radius, and that's the intercepted arc. It's, if you can see the last letters, right? A, B. That's going to be where it intercepts, because P is the center. This is circle P. All right, let's set up the proportion for area of a sector. All right, remember, this is area of a circle. That's what this formula is, okay? Again, the measure of the arc in degrees over 360. So literally the second part of this proportion is exactly the same that we were working on the other day. So the area of the sector could be what you're looking for. So X could be here, X could be here, X could be here, but it's never going to be there. So know that little peace of mind. And we always want to make sure that this is measured in degrees. We don't want no radians here. Can you imagine? You guys would kill me. All right, so we have an example here. It's on the next part of your paper. We're going to find the area of this sector. So we're going to use this fancy little proportion formula. I'm looking, this little area, this is X in here. I don't know what that is. It's not arc length. It's the piece of the area of the circle. So X over 2 pi r. Oh, that's circumference. Pi r squared. Pi times 5 squared is equal to the measure in degrees. Remember, this is a central angle, so this is also 54 degrees over 360. And we're going to cross multiply, guys, because that's what we be doing. All right, when I cross multiply here, that's easy peasy. 360x. When I cross multiply this way, well, pi times 5 squared times 54, and round to the nearest tenth. That gives me 4,241.2. Please make sure you can put this in your calculator so you know how to do it. All right, and if you don't have a calculator by now, that's your own fault. You should have one, because I've been saying it all semester. All right, so now all I need to do is divide both sides by 360. So 4,241.2 divided by 360 is 11.8. Now, because we're talking about area of a sector, it's going to be units squared. Units are inches, inches squared. You will lose points if you do not label your numbers, right? Area is always squared. Everything else is just what it is, okay? Let's continue with our practice problems, guys. All right. Now, it says area of a sector. That's all this out here, all this gray area. I don't know that. Area of the sector is the numerator. Pi r squared is the denominator here because that's the area of the whole circle. So pi times 12 squared is equal to the measure in degrees of the gray part, so 288, over 360. Great. 360x. Pi times 12 squared. Oops. Times 280 is a big number. 130,288, and if I round to the nearest tenth, 0.1. So 130,288.1, divide that by 360. X is equal to 361.9 units squared, because it's area of a sector. Area is always units squared. All right. I will say on your homework, you have to find both. You find the one side and then the other side, so make sure you're doing them twice. I think it's numbers. Oh, I'll have to. I think it's 11, 12, 11 and 12 for sure. And then 13 perhaps. But make sure you're reading the directions on the homework so you know what you're doing and you get the practice that you need to have success. All right, again, area of a sector. That's X up here. Look at that. Pi r squared. Pi times 10 squared. because r is 10. That's the radius. Equals the measure of the gray angle, 144, over the whole circle, 360. Cross multiply. 360x. Get out your fancy calculators. Pi times 10 squared times 144. 45,238.9. Round to the nearest tenth. Dividing that by 360. So 45238.9 divided by 360 is x is equal to 125.7 centimeters squared because it's area. All right. Now we have a couple more to do and we're donezo, right? Well, I guess a little more than a couple. That's okay. We have a few. It'll be fine. All right. We're going to use the diagram to find the area of the circle. This, A equals 35m squared, that's the area of this piece of pie. That's the numerator. The denominator for that piece of pie is the whole area of the circle. I'm going to let that be x. The measure in degrees is 40 over 360. Not that difficult. We're going to cross multiply. 40x equals, and then 35 times 360 is 12,600. Divide both sides by 40, and x is equal to 315. I don't like the way that looks. 315. The units is meters, and it's squared because it's the area of the entire circle. 315. All right. Great. Next. It wants us to find the area of the shaded region. All right. First off, if you notice in 4, it's the whole freaking circle. Please don't set up a proportion. You're finding the area of the circle. Area is pi r squared. So area is equal to pi times 9 squared. When I put that in my fancy little calculator, you should get 254.5 inches squared. I'm just going to double check and make sure my math is mathing. 254.5. Correct. All right. This looks like treachery here, okay? So I'm going to show you something. First off, these hoops are saying that this is identical. This is also 130 degrees over here, okay? The radius is still the radius. It's just 7, okay? So it wants the area of the shaded region. The area of the shaded region is a sector. It's a portion of the area of the circle. That's the numerator. The formula for area of a circle is pi r squared. R is 7. Pi 7 squared. Now, here's where I want you to use your big brains, okay? This is 130 degrees. This is 130 degrees. What measure in degrees am I talking about here? Because I'm talking about both of those shaded areas. 260. Because 130 and 130 make 260 over the whole circle. All right, so make sure I'm including that. Make sure you're including that. I know how to do this, all right? So when we cross multiply, I always do the easy one first. 360x, then I bust out my fancy device and I'm like, pi times 7 squared times 260 gives me 40,000. 23.9. All I need to do is what? That's right. I need to divide by 360. All right, so when I divide by 360 and I round to the nearest tenth, I get x is equal to 111.2. What are my units? Inches. And it's talking about area, so it's squared. All right. Now, this next question is very strange, and I'm going to try to explain it, and it is definitely going to be a test question, so please pay attention to what I'm saying, okay? This is the center of the circle here, okay? So from the center to this part, there's a hash mark. From that part to this part, there's a hash mark. So this, from here to here, is 19. From here to here is also 19. So what is the radius of the big circle? Well, hopefully you can multiply 19 times 2, and you get that this is 38. All right. Now, there's a lot of stuff happening here, okay? Because, first off, I have half of a circle. I'm not setting up a proportion, okay? We're talking about a whole circle while we're talking about portions of a circle, parts of a circle, but not sectors of a circle. This is not a sector. It's not a piece of pie. All right? So if you think about, if I ignore all of this circle over here and I just have half a circle, half of the big circle, well, the big radius is 38. Half pi 38 squared minus, now we're going to ignore this part of the circle. We're just going to focus on punching out or subtracting out this half. I'm subtracting out this half of the circle here. I'm punching this part out of my half, right? I'm really only focusing on half of the circle. So remember what I said, that this to here is again 19 centimeters. That's what these little hash marks mean. That means those segments are congruent. Okay, so we're subtracting out half of my little circle with radius 19. That's how we do it. So this is half of entire circle minus half of inner circle. That is the formulas that we have, okay? Now let's punch this in our calculators and get to it. What the heck? So half 1 divided by 2 times pi times 38 squared minus 1 divided by 2, which is a half, times pi times 19 squared. And I round to the nearest tenth for the love of cheese. It's 1,701.2. 1,701.2 centimeters squared. That's all of this. Right? All of that. That's just that part. It's like half a donut. Okay? That's probably what I should have wrote. We took half of the whole circle minus half of the inner circle equals half a donut. I know. I think all of you love donuts. I'm not sure, but I actually don't. They give me a bellyache. I mean, I love them. They smell delicious, and they taste delicious, but I just don't feel good afterwards. All right, so it wasn't an area of a sector, right? It was a circle, subtracting out the white space. Just like the next two we're going to talk about. We're not going to be talking about this area of a sector, so I'm not setting up a proportion, but I wanted you to use your brains here, okay? The radius is 8. The radius goes from the center to the edge of the circle. This is also 8. This is also, I meant to change color. This is also 8, making this portion from here to the edge of the circle 16. Okay? These circles are identical. So this is also 16, making the whole thing 32. All right? Again, this is also the radius, which is 8. So I hope you can see that makes the whole width here 16. All right. So to find the area of a rectangle, You simply take length times width. Okay? So we can find the area of the rectangle, and we're going to subtract out 2 circles because there are 2 identical circles, 2 congruent circles. Okay? Oh, not meters, silly goose, inches, inches, inches. Stay at the right units. Okay? So first I'm going to take the area of the rectangle, length times width. Length times width. So 32 times 16. Area of rectangle. We're going to subtract 2 circles. Pi r squared. Two circles with radius equal to 8. Okay? Get your calculators out and start typing this in because that's how simple it is. Is this calculator work, guys? So 32 times 16 minus 2 times pi times 8 squared. Oh, interesting. Oh, okay, I did something weird. Okay, so that's why we're doing this together. 32 times 16 minus 2 times pi times 8 squared. My calculator gave me a negative number, and then that's why I had to laugh, because I was like, wow, that's freaking wild. If we round to the nearest tenth, 109.9 inches squared. That's the area of the shaded region. Shaded parts. How about that? Right? We took the area of the rectangle, we subtracted out 2 circles, and that's what we're left up with. Right? This gray stuff in here. That's how we do it. It's not rocket science, guys. It's not terrible. I know you can do it. All right, the last one is a real humdinger. Get ready. Are you ready? I hope so. I'm ready. I'm going for it. Oh my goodness gracious. They give us this hypotenuse that doesn't mean anything to me. I know that this is the radius and this is the radius. So guess what? I need to find the radius first so I can find the area of the circle and subtract out those triangles. All right? Formula update. Area of a triangle is 1/2 base times height. Let's find this radius business so I can get to it. Right? This is a right triangle. Leg squared plus leg squared. We're going to use the Pythagorean theorem to find the radius. But fear not. We don't have to keep it in radical form. That's the good news, guys. All right? R squared plus R squared, 2R squared. 5 squared, 25. All right, no big deal. Divide by 2. R squared equals 12.5. Let's square root this Jimmy John. All right, so get your little calculators out. Square root 12.5, round to the nearest tenth. That means R is equal to about 3.5. All right, remember, the radius is any portion from the center to the edge of the circle. So if the radius is 3.5, the whole thing here, which would be the diameter, would be 7. Okay? We need to know that because that is for my area of a triangle. So first off, we're going to take the area of the circle. We're subtracting out the white space. So the area of the circle is pi r squared. Pi times 3.5 squared. Subtract out the area of the circle. 1/2. The base, the whole base, which is the diameter, 7 times the height, which is the radius again, 3.5. So what this is the area of the circle and we're going to subtract the area of the triangle. Okay? Get your calculator out. Pi times 3.5 squared minus 1 divided by 2 times 7 times 3.5 is, if we round to the nearest tenth, 26.2 inches squared. All right, fantastic. Your homework's a lot of something like that, okay? Make sure you're practicing and you're understanding and trying hard. Watch this video again if you need to. But I wish you the best of luck. All right, guys. Make sure you show your notes to the sub so she can make sure that you did what you're supposed to do. And I don't have to email any of your parents or anything like that. And I hope you have a great day. Bye. Oh, I forgot to give you your homework. And please disregard that it says 60 because it's not. It's 11.2. So make sure you do all that work. I will say that all of the math teachers here at Conrad Weiser know how to do geometry. So if you are struggling, you need to reach out for help. The woman that is a substitute was a math teacher, so she should also be able to help you. And I don't want to hear any crying. Okay? And have a great day. That's it. Bye-bye.